Okay, going to be doing the solutions here for, what is this, 7.5, the unit circle approach to the trig functions. So we're going to start off with number 9. It says, which of the following is not in the range of the sine function? So you have your sine function, and on the unit circle, we know that given some angle, theta, since this radius is 1, we know the sine is the y-coordinate. This is sine of theta. So it says, which of these numbers is not in the range of sine? So which of these numbers could not come out of this? The first one is pi over 4. Well, pi over 4 is approximately 3.14 divided by 4. That number is smaller than 1. And notice that with the y value, anywhere on this circle, the highest y value you could have is 1, okay, because it's a unit circle, and the lowest y value you could have is -1. So we know that the range of the sine function is between -1 and 1. We know it's got to be between here. So it's possible that this would work, okay? We could get that number out. Now part B says 3 over 2, but that is bigger than 1, so that's not possible. Part C is -0.37, and that's definitely between -1 and 1, so that one could work. And part D says -1, and yes, it is possible to get -1 out of the sine function if you're all the way down here at the bottom. So the only one that can't be in the range is this one. All right, for number 13. We're asked, it says the point P on the unit circle corresponds to the real number T is given. Find sine T, cosine T, tangent T, all 6 trig functions. So it gives you this -√2 over 2, -√2 over 2. All right, so that is a common point on our unit circle. So here's our unit circle, and it's negative, so we're down here, and it's that perfect diagonal right there. And so if we want to know what sine of that angle T is, it's going to be the y-coordinate, so it's -√2 over 2. If we want to know what cosine of that angle is, it's going to be the x-coordinate, so that's -√2 over 2. And then tangent of that angle, T, is this divided by this, and since they're exactly the same, that's just going to be 1. And then cosecant is this flipped over, secant is this flipped over, and then tangent is that flipped over. So that's it for 13. Now number 17, a little different. Number 17 gives you a point, 3, -4, and it says it wants, use the fact that the trigonometric, wrong thing. This is a point on some circle with some radius. Find all 6 trig functions. So this is very much like the last section. We imagine that we have this point, we go out 1, 2, 3, and we go down 1, 2, 3, 4. So we've got this point here, 3, -4. And so what we need to determine is this radius. So what we do is we construct a right triangle here. We know that this is 3 and this side's -4. And again, the side is -4 is just the fact that it's down. So if we do Pythagorean identity, a squared plus b squared is c squared, we can find that this side is 5. I'm not going to show that work because we've used 3, 4 a lot. So that side is 5. So now I can get all my trig functions. Sine of theta, so we're saying that the angle here, theta, is that angle. Sine of theta is y over r, and our radius is 5. So y-coordinate is negative, so we get -4 over 5. Cosine of the angle is x over r, which is 3 over 5. And then tangent of this angle is the y over x, so -4 over 3. And then cosecant is this flipped, secant is this flipped, and tangent, cotangent is that flipped. So that's it. That should look very, very similar to what we did last section. And so is the next problem. 21. Different point though, -1, -1. So that's going to be to the left 1, down 1, right here. -1, -1. So I could again construct a little right triangle here. -1, -1. So if I wanted to find the radius, I could do a squared plus b squared is c squared. So I could have -1 squared plus -1 squared equals c squared. Or you could say, let's say r radius squared for r, because that's usually our radius. So this is going to be 1 plus 1 equals r squared. So this is 2 equals r squared. So root 2 is r. So now we know what r is. Sine of the angle is y over r. So y is -1. So -1 over root 2. Cosine is x over r. So again, -1 over root 2. Tangent of theta is the y over x. So -1 over -1, which is 1. And then we could get all of our other 3 trig functions by just flipping those over. And let me take this text, see what this text is real quick. Okay. Okay. Now, moving on to the next one, which is 27. So we want to find the exact value of the following thing. Don't use a calculator. What is cosecant of 450 degrees? Cosecant of 450 degrees. So this is equivalent to 1 over sine of 450 degrees, just using the definition of cosecant. So let me figure out where 450 degrees is. So what I could do to see if this is a common angle is I could say, okay, all the way around is 360. That's actually more than that. So if I take 450, I subtract 360, right? I'm going to get 90 degrees. So that means that I'm actually all the way around and then up to 90, so I'm like right here. So I went all the way around and back to here. If I use the unit circle, this radius is 1, then this is a very special point. It's the point 0, 1. So if I want to know what cosecant is, it's 1 over sine. Well, sine of this is the y-coordinate, so that's just 1 over 1. So we should just get 1 here. So cosecant of 450 degrees is 1. Let's try this for another one, 33. Tangent of 21 pi. 33. Tangent of 21 pi. Now, I need to figure out where 21 pi is. Now, there's a lot of ways I could do this, but let me just think through this. Here's the unit circle. If this is pi, that's 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. Notice that all my odd pi's are right here, and all my even are over here. So all my odd pi's are there. So if it's 21 pi, it should be here, and that's a special point. That's the point -1, 0. And because of that, tangent, by definition, is the y-coordinate divided by the x-coordinate. So it's 0 divided by -1, which is just 0. So we should get 0 for number 33. Now number 37 is 19 pi, tangent of 19 pi over 6. 37. So I've got to figure out where 19 pi over 6 is. Well, again, I use my common knowledge of the common angles. So pi over 6, that's 19 of them. So pi over 6 is here. It's 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7, 8, 9, 10, 11. We know 12 pi over 6 is 2 pi, right? So that's 12, 13, 14, 15, 16, 17, 18, 19. So I'm right here. That's a common angle. You should have that memorized. That's negative root 3 over 2, negative 1/2. That's the x and y coordinates. And I want to go and take the y coordinate and divide it by the x because it's tangent. So I'm going to take negative 1/2 and divide it by negative root 3 over 2. This is the same as negative 1/2 times 2 over root 3. So I'm just multiplying by the reciprocal. The 2's cancel. I get negative 1 over root 3. And in the book, they're going to rationalize the denominator, which I haven't done that in any of these problems, but let me just show you on this one. I multiply top and bottom by root 3. I get negative root 3 over this and this together is just 3. So that's the book's answer. This is the way you could do it on a test. But just be able to recognize this, okay? If you ever see this, you should know that you're talking about this angle. All right, number 39. Use the even and odd properties to evaluate the following. So number 39, we want to know what sine of negative 60 degrees is. So no calculators. Now we could just go to negative 60 degrees, but what we're going to do instead is use the even and odd properties. So sine is an odd function, which means this is equivalent to negative sine of 60 degrees. All right? So the negative, if you have a negative in a sine, you can almost look at it like the negative comes out. Okay? So we have that. So 60 degrees is right here. That's a common point. So it's that. And sine is the y-coordinate, so this should be negative and then root 3 over 2. We would have got the same answer had we just done the original problem. Here's negative 60 degrees. This is the point 1/2 negative root 3 over 2. And you can see that the y-coordinate, right, sine is the y-coordinate, would be negative root 3 over 2. So they just want us to use the property. Okay, so how about tangent? That's the next one, number 41. So tangent of negative 30. So tangent is also an odd function, so this becomes negative tangent of 30 degrees. And so if we go to 30 degrees, that's here. This is root 3 over 2, 1/2. Tangent of that is y over x, so I have negative, and then I have 1/2 over, don't forget the negative out there, root 3 over 2. And if I flip this up, I get negative 1 over root 3. And we did that earlier, rationalizing denominator, you should get this. So the negative just came for the ride here. All right. Now let's move to number 45, which is sine of negative 90. Sine of negative 90. Degrees. So for this one, again, sine is odd, so this is negative sine of 90 degrees. 90 degrees on our unit circle is straight up. Up here, 0, 1 is the point, sine is the y-coordinate, so it's just going to be negative and then 1, so negative 1. Let's see what the next one is. Number 47, tangent of negative pi over 4. So tangent is odd, so we can go negative tangent of pi over 4. Now pi over 4 on our unit circle is here. That's the common angle, so root 2 over 2, root 2 over 2. Tangent is this divided by this. So that's just 1, but we had a negative out front, so just negative 1. All right, number 53, cosecant of negative pi over 4. Cosecant of negative pi over 4. Okay, so cosecant is also odd, so this is the same as negative cosecant of pi over 4. But that's just negative 1 over sine of pi over 4. That's what cosecant means. And so I'm actually at the same angle, pi over 4. Sine is just this coordinate. So this is going to be negative 1 over root 2 over 2. And 1 over a fraction flips it, so we just get negative 2 over root 2. And then you could rationalize the denominator, but I'll just leave it like that. Number 55. Finally, we get to an even function, secant of negative pi over 6. Number 55. Secant of negative pi over 6. So secant is an even function, which means that the negative here, it's equivalent to what you get with the positive. So no negative comes out, it's just like the negative goes away. And we need to go look at pi over 6 to be able to figure out what this is. Also remember, secant is 1 over cosine. So this is 1 over cosine of pi over 6. So we go to pi over 6, right here. This is root 3 over 2, 1/2. Cosine is the x coordinate, which is this one. So it's 1 over root 3 over 2. And so you flip it and it becomes 2 over root 3. And if you rationalize, I'll go ahead and do it this way. If you rationalize, you'll get this. All right. Find the exact value. Do not use a calculator. Number 57. Let's see what this is. All right, 57, sine of negative pi plus cosine of 5 pi. Sine of negative pi plus cosine of 5 pi. All right, so I'm going to do this one. I'm not going to use the even or odd properties. I'm just going to use my knowledge of the unit circle. So where is negative pi? Negative pi, go backwards, we're right here. That's the point negative 1, 0. And we want sine of that, which is the y coordinate. So that's just 0. This is 0, plus, now cosine of 5 pi. 5 pi is, let's see, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. So we knew it was odd pi's land over here. We want cosine, which is the x coordinate. The x coordinate is negative 1, so this is just negative 1, so the answer is negative 1. So we didn't need a calculator at all for that. All right, let's try number 59. We have secant of negative pi, and then we have plus cosecant of negative pi over 2. All right. Negative pi is here, so we're talking about this point again. And secant is the same as 1 over cosine. So this is the same as 1 over cosine of negative pi. And cosine of negative pi is the x coordinate, so this is just going to be 1 over negative 1. So this is just going to be 1 over negative 1. Now we still have plus. Now cosecant is 1 over sine, so 1 over sine of negative pi over 2. Now negative pi over 2 is negative, so we're pi over 2, it's straight down, we're here. This is the point 0, negative 1. And if we're looking at sine, it's the y coordinate, which is negative 1. So we have plus here, we have 1 over negative 1. So we have negative 1 plus negative 1, this is negative 2. Number 61. Sine of negative 9 pi over 4 minus tangent of negative 9 pi over 4. All right. Well, it looks like we're using negative 9 pi over 4. See if we can figure out where that is. Okay, remember, this is pi over 4, 2 pi over 4, 3 pi over 4, 4, 5, 6, 7, 8. So that's where our pi over 4s are. But I'm going to go not counterclockwise. I'm going to go clockwise because I'm going negative angle. So here's 1 pi over 4, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to wind up right here. That's the point root 2 over 2, negative root 2 over 2. All right, so sine of that angle is the y-coordinate. So this is negative root 2 over 2. Minus tangent of this is this divided by this. So if we divide those, they're the same, but they're opposite in sign, so I get negative 1. So that's minus negative 1. So we have negative root 2 over 2 plus 1, which you can just leave it like that. I'll write it another way. 1 minus root 2 over 2. The most you could do here is get a common denominator. You could turn this into 2 over 2, minus root 2 over 2. And then if you put these two together, you get 2 minus root 2 over 2. So either this or this. Let's see what the book has. The book has this, but this is fine. It's the same answer. All right. Number 63 through 73 odd. So I think I'm just going to verbalize the answers to these. Maybe. Let's see. What is the domain of the sine function? So when you look at the sine function, you look at a circle, the sine of an angle is the y-coordinate. Now we know the range of the sine function is between negative 1 and 1, but this is asking for the domain. So the question is, what are the angles you can plug in? Well, you can have any positive angle, and you can have as big as you want. You can have any negative angle as big as you want. So the domain of this is all real numbers. So from negative infinity to infinity. All right, next one, number 65. For what numbers theta is f of theta equals tangent theta not defined? So if we have a function and we define it to be tangent theta, when is it not defined? Well, remember, tangent is sine of the angle over cosine of the angle. And the only way this would ever be undefined is if cosine happened to be 0. So when we go back to our unit circle, cosine is the x-coordinate. So where would the x-coordinate be 0? And that would be here or here. Now, how could we illustrate all of those possible answers? Because remember, there's an infinite number of answers here. So what we can do is we can say, look, if you start out by getting here to pi over 2, so if theta is pi over 2, plus, to get from here to here, we'd have to add a pi, and then we'd have to add another pi to get back up here, and then back around. So what we could say is pi n or pi k, so starting at pi over 2 and then adding any multiple of pi, either counterclockwise or clockwise, we're going to start knocking out both of these 2 points. And those are the places that this thing is not defined. So we would say that it's asking us, where is it not defined? And we're saying at whenever theta is pi over 2 plus pi n, this tangent function is undefined. Hope that makes sense. Okay, now it asks, when is secant undefined? So it's saying, what if you define a function to be secant theta? Well, secant theta is 1 over cosine of theta. And the only way this is going to be undefined is if cosine is 0. Well, that happens to be the exact same places that this previous problem was, 0. So we actually have the same exact answers for secant. Now, what is the range of the sine function, number 69? We've already talked about that. The range of the sine function is between negative 1 and 1, including negative 1 and including 1. It says, what is the range of the tangent function? This one's a little bit harder. The range of the tangent function. How can we illustrate this? You know what? Let's not illustrate that now. Well, I'll try it. Okay, so what is the range of the tangent function? I'm asking, what is range of tangent? So what possible outputs can we get? Well, tangent of an angle is sine over cosine. And on a unit circle, let's just look in the first quadrant what happens. Here it's 1, 0, and here it's 0, 1. So if you take any angle over here, and you take the x and the y coordinate, tangent, what you're going to do is take the y and divide it by the x. So if I start out here at 0 degrees, this divided by this is 0. So I definitely can get 0 out. 0 can come out of this function. Now if I start moving like this, okay, what happens is that if I'm over here, let's say right here, I have a very small y coordinate and a very large x coordinate. Think of it like a little triangle. Small x, big y, right? I said that wrong. Small y, big x. If I have a small y and a big x, that's going to be a small number. So I can get small numbers out of this, small positive numbers. And as I start to move up like this, let's say I get up to here, now I have a large y and a small x. So what happens if you have a big number here and a small number here? That number gets really big. So I can get big positive numbers. In fact, as I start getting really close, I have a very large y and a very small x. So this number gets almost like astronomically big. And if you get vertical, you get 1 divided by 0, which is undefined. So what happens here is you start at 0 in the tangent function, and then as you move this way, you start getting bigger and bigger numbers. So it's looking like it starts at 0 and gets big and becomes almost infinite. Now, if we start and try and go backwards, let's say if we do tangent over here, we would have the same principle. We'd start out with small numbers and they would get really big. However, they would all be negative numbers because we're in the fourth quadrant. So, you know, remember over here, your x and your y is negative, your x is positive. So we're going to get small negative numbers, and then they're going to become big negative numbers. So at the end of the day, the tangent function has as its range everything from negative infinity to infinity. It can cover everything. All right, so for secant, the range of secant, secant or cosecant? Secant. The range of secant, only thing it changes is that this is 1. Right? So this one's a little trickier. And we're going to talk about this a lot. I just don't know if I want to do it. I don't want to do it this way. It's not as constructive. Secant. Let's wait on that one. Maybe you can figure out what the range of secant is. But at this point, I'm not ready to really go into that. All right, I think that's it. Yes, okay, that'll cover that section.